There we go. All right. Well, I can make up problems, do a little sampling of everything, which is kind of what you expect on the test. I think there's 10 or 11 questions on the test. A little of everything. Chapter 2, solving equations, starting fairly basic, and of course getting more complicated, parentheses, maybe fractions, things like that, and then solve the formula for one of the variables. I'll set up and solve those word problem equations in chapter 3, including a geometry-like problem or two, Pythagorean theorem problem. So, should I just put some things on the board, or would you like to suggest something that I should go over?
Can you go over percentages?
Okay, there we go. Thank you. Now, let's see. So, what's the other one I'm missing? All right, so I started out with what I call like the 3 basic types. In our percentage problems, there tend to be 3 numbers: a percentage, starting value that we take a percentage of, and then the resulting final value. And any one of those 3 values could be the missing number in our problem. And so here I started with 3 sentences that we like to be able to translate from the sentence into the equation. And a couple things to remember: that is always where the equal sign is. Of means multiply. And if we have a percentage in that statement, we always have to convert it to the decimal value to use it in our equation. And if we're looking for the percentage, we get a decimal, and we have to convert that decimal to a percent. So looking at these 3, I try to make up one each of the 3 different varieties here. I'm going to squeeze it in here, all right? 35 is 25%. I'd write it as 0.25 of what? That's what we're looking for, so that's what our variable is. 35 is 25% of what was the bigger number to start with. I'd like to think that if you can get this far, now it's an equation that follows one of our basic solving rules. Here I would divide both sides by the 0.25 to figure out what that starting value is. I made up an easy number just to discuss it and put it out here, but basically, what's 1/4 of the starting value? What 35 is 1/4, so what is it? That should end up being what, 140? If I did 35 divided by 0.25, that would be our final value. So 140, I think, is what you'll get there. All right. What percent? So there's what we're looking for. We're looking for the percent. Just because that's the one that's kind of different, I usually present it with a P for the percent. What percent of 16? Some percent of 16 is 12. What part of 16 gets you 12? All right. So still, we're going to divide both sides. And I get P equals 12 divided by 16. And I think you'll see that's 0.75 with a decimal. Converting that to percent, always 2 places, 75%. I'm going through these kind of quickly, I guess, Slow me down if necessary. All right. And what is 45% of 200? The third one. What is 45% of 200? Just the way that was phrased, that the one where the variable is already alone. We just need to do that calculation. And again, I did numbers. I think I can do in my head there, but plug that in your calculator, I think you'll get a 90. So there's one each of the basic types, right? Then we get into percent increase or percent decrease. Okay? So I'll move right on. If those three are okay, double check nobody else is reading. All right. And so and again, not trying to make too complicated the numbers. If you can get yourself set up, the calculator will usually help you with well, doing the actual divisions or whatever you need to do. So here I'm saying a value started at 20 and it increased to 25. You might be able to just do that in your head, but we're looking for a sort of process here to use. So it did increase. What is the percent increase? So percent increase, that's that one where you want to find the amount of change first. How much did it change by? Well, it's always just a difference, a subtraction problem. So it changed by 5 points, a value of 5. So then we always compare to original. Compare that amount of change to the original value. 5 is what percent of, and 20 was the original. So that's that two-parter here. Percent increase or percent decrease tends to be a two-part. Find the amount of change and then compare that amount of change to the original value, whether it went up or whether it went down. You know, how much did it change by? Did it increase or decrease? So here we'd be saying 5 is what percent of 20? Dividing by 20, I'd get, 0.25 and call that 25%. Right? We're not from the 20 at 1/5. 5 is 1/4 of it, right? Just talking round numbers, familiar numbers. So percent increase or percent decrease, if you're looking for that amount, percent change, then find the amount of difference and compare it to the original. Do that subtraction there. Then there was a third type. All right, that's okay. Just keep going. All right. All right. Find the original. So a dress is on sale for $70, down 75%. It's been reduced 75% from its original price. They're really trying to sell it, move it. What was that original price? Similar to the last kind where you kind of have to do a first step, an initial step before you do your actual calculation. Here we're not looking for the percent change, we're actually looking for one of the original value. If it's on sale 70%, 75% off, here's where I say Well, what percent are you actually paying? Right? Because it's 75% off, you're paying the percentage that's left. So you're paying 25%. 70 is 25% of the original. Of what? You know, that's what we're looking for. In all of our word problems, you really kind of want to focus on what are we looking for? What's going to be our variable? Right? 70 is 25% of what? Again, I made up numbers I could work in my head really. I think you see that was a $280 dress. It's now on sale for $70. Watch out for the need to put in units and the way the problem's presented to you. So there's an example of it's been reduced from some starting value. Find that starting value. Another version of that is that kind where you know what you're paying after tax or after the tip. What was the starting amount? I'll just try to make something up like that too, okay? Again, tell me to wait. You need to, all right. And oh, who knows? Messy numbers. Whoop, $65, not percent, Steve. What was the bill before tip? All right. Again, you know your final amount, which includes an additional 15% beyond the dinner price or whatever it was you paid. So again, what percent do you pay or are you paying? What percentage are you paying of the original? Well, if I'm adding 15%, I'm paying 115% of the original bill. Original 100% plus another 15. So 65 is, well, 115% of what? Convert that to a decimal, right? 65 is 1.15x. Dividing both sides by that 1.15. Look, clear. And yeah, I made a messy number here. Let's call it 5652. How's that for a real quick review? So you have that sort of basic type, I call it, where you're presented that statement. Where is it? Like there, that sentence, translate it and solve. We have percent increase, find the difference, how much to change by, and then compare that to the original. And then looking for the original after you've added tax or something like that. And so you find you have to figure out what percentage you are actually paying, add or subtract the percentage amount, figure out what you're paying. All right. Next. Here we go. All right. Clear the board? Put up an equation, solve something. Oh,
Can you do more fractions?
you want with fractions, huh? Okay.
Yeah.
There we go. And I suggested early on, when we first did this, that if you don't mind working with the fractions, you can just add and subtract fractions and be careful and get what you get. The technique, though, that we suggest is let's multiply to get rid of all the fractions. So what we're going to multiply is that least common multiple, basically the common denominator of all the denominators in the problem. What number is a common denominator for all of those? I think, hope you see it has to be a 12. So I'm going to multiply everything in that problem. And here I'm going to shortcut. I'm going to multiply everything in this problem times 12. Every term. It's like 12 over 1. It's not 12 over 12. They'd all have a common denominator if I did that, I guess, eventually. Well, no, not quite. Anyway, so I always kind of show this by just do the multiply first, and then you'll see the fraction simplifies. Any question about that step so far? Just find that common denominator, and I'm going to multiply the numerators. 36 over 4 minus 12 over 3. 12 of this gets me 12 over 2. And what's that? 60 over 6. That was just multiplying, made everything 12 times bigger. It's all proportionally bigger, so it's still balanced. But simplifying that fraction, lowest terms, no more fraction. No more fraction. And that's usually the goal of this process. Get rid of the fractions, and now it should look like something a little more manageable, huh? Looks like I'm going to subtract the x's here. 3x minus 4 equals -10. Leave the x's alone, and I'll add 4. Boing, boing. Clamp that board someday. Divide by the 3. And I got a -2. Is that a good enough refresher? Get rid of the fractions. Yes, you will see something like this. Not any trickier than that. It's tricky enough, I guess. Just remember, for instance, if there was an integer value, like a -1 in here or a -2 or something, just a whole number, that still has to get multiplied by whatever you're deciding to multiply to get rid of the fractions. There just wouldn't be a fraction in that one to get rid of. But you still have to make every term, in this case, 12 times bigger. Okay, here we go. Yeah. All right, what's the big deal here? Just put up an equation to solve. Well, it's got grouping symbols, it's got parentheses. Usually that means we have to distribute something, some number outside times everything that's inside. Now this one, got notes from some time in the past. You don't see any values, but this one's all about the negative signs. All right? I'm subtracting each of those two numbers. So in a sense, I'm distributing -1 times both of those, and similarly over here. So I have to distribute that negative sign. It's always unfortunate when you guys work out these problems and forget to distribute the negative to every term there. This one is just 1 times each of those. I don't really need the parentheses. But here I have negative times both of those. Negative 3x, negative times negative, and positive 7. 20 is just there. And again here, negative times both of those. Negative 4x, negative is plus 2. And that's what that example was all about, primarily, is distributing that negative sign. Now I've got like terms to combine. We'll move stuff around. How many x's over here? Just on this side. I'm not adding or subtracting anything to both sides yet. I'm just compressing what's here. I see students, try to do this or something. No, I'm not trying to cancel it out. I'm just combining them. I have 9x's minus 3 on this side. I just have 6x's. I have a 5 plus a 7, so I have 12 on that side. On this side, I have 20 and 2 and some x's. Yeah, I'm glad. I guess I kind of remembered to point that out. I see people trying to use our, you might say, canceling process, when really all you want to do is combine the like terms of this stuff. But now we do need to move everything, variables to one side, constants to the other. Let's add these x's. Now we're canceling, you might say. We're canceling those over there. Right? And subtract the 12. And that makes sense. 1. That's about as messy as, well, between that and the fraction question, right? About as messy as just the plain equations that are word problems. That's about as messy as I get. You might have a number outside to distribute. But having a bunch of terms that you have to distribute something and then combine the like terms, that's about as complicated as our problems have been. Okay. Another one for some reason, like similar to that last one. So I do have some distributing to do. 21 times each of those. Negative 19 times each of those. Minus 19, right? Just 2 times each of those. Got some like terms over here. How many x's? 21 minus 19, 2 x's. How many constants? Negative 21 minus 19, negative 40. See what this one's all about? What's going to happen? Okay. This is one of those classify this equation. What kind of equation is this? Is this weird or is this normal? Put it that way. Is it one of our two unusual types, or is it just a conditional one where it works just for one value. If I try to combine all the x's, I get no more x's. They cancel each other out. And now I just have this always true statement. Identity or a contradiction or a conditional. Those are those three terms. You got to know what they mean, which one is which. An identity, right? Any value, an infinite number of solutions. Any value for x would make this true. If there's the same number on each side, it was always, whatever I put in there, would always be true. If I did all this work and it boiled down to something like 5 equals 7, that's that one that's, you know, even without the variables, that's a false statement. That's the contradiction. That's the one I like to think that word has the negative connotation. You know, no solution. And most everything else that we work with, is called a conditional equation. There is one condition that makes it true. X equals 5 or something. Conditional. So you will be asked to classify an equation. You boil it down to basically one or other of a statement like this, something that's always true and it's not dependent on x. If you've got an x left in there, then it means x is going to turn into something. But if the x's all go away, then it's going to be one or the other of these. Mm-hmm. That's where I usually say, and then they kind of hide it, all that distributing and stuff we had to do at the beginning, so it wasn't just obvious what kind of problem it was, huh? You do that one? Solve that formula for the B. When I look at this, you know, it is multiplying by 1/2 or dividing by 2. I usually just say, let's cancel out that 2 first. Multiplying both sides by 2. That looking 2 there, right? Gets that to go away. Careful what you're after. Be sure you know what you're looking at. Which one am I supposed to get alone? The B. So B is being multiplied. So here I'll just divide by that H. Something like that. How about another one goes? How about solving this one for the x? There's the x. So this term has this other term added to it before it equals to c. I want to get this x alone. So just like adding or subtracting some extra number, I'm going to subtract that dy from the c from both sides. Really, I'm kind of doing this. By and to get the x alone now, I need to divide both sides by a. And I've seen some of you do this either of the couple of ways. Yes, every term gets divided by a. That's okay, right? That's totally true. And you can leave that one like that. Some of them, there's one version, right, where there's a 2, where you divide both sides by 2, and If it cancels, fine. Or just doing the entire fraction divided by a, but just be sure that you check your format, your syntax, mom would call it, right? Make sure that it, preview your answer. Make sure it looks like what you mean it to look like. If I did something wrong, it might just look like only the by was divided by a or something like that. Okay, solving a formula for one of the values in the formula. All right, call them out, but if you got something in mind, I'm just making up problems here, throwing them out at you. Let's see. 2 sections of a field being fenced, extra fence down the middle, 90 feet of fencing. It'll be, written out full sentences. Length is 4 feet less than twice the width. Find the length and width. Here's one of those. It's kind of like a perimeter problem. Remember I said you should know perimeter is twice the length plus twice the width. But here, because of that extra piece of fencing, all right, I'd say I have, let's call it, I'll call it perimeter, but it's twice the length plus 3 times the width. All right, there's 3 widths in this figure. So there's my made-up formula for this problem. Now I have a relationship here. The length is, really I'm saying length is 4 feet less than twice the width. Length equals 2w minus 4. It's like a mini side equation here. But I'm going to use this instead of the L because I don't want to have 2 different variables. Otherwise, I really can't solve for either of them. But I know now that my total, so you want to have to be able to pull that out, right? Translate. So the 90 has to equal 2 of the lengths. Well, this is the length. That means I need parentheses for that more complicated expression. It's not just an L. And don't forget, don't lose your rest of your W's there. So that's getting to the equation from the drawing and the information in the problem. It'll be a total of 90, whatever, and then you've got to be given some relationship, whether it's triangles or something else. Right? 2 of each. Got a bunch of W's over there. I add 8 to both sides. 98. I'm thinking ahead already. My hand. It's funny the way the brain works. All right, dividing by the 7. And then I get a 28, and so that's 14. These would be, yeah, feet. Okay, 14 feet. What was that? That was the W, all right? The W is 14 feet. I'm looking for the length also. Go back to your relationship. The length was in terms of the width. So the length is 2 times 14 minus 4, 28 minus 4, 24 feet. we did versions of this kind of problem where a triangle was described with some relationship. One angle is twice the first angle, and the third angle was a couple less than this, first one, or something like that. But you had to know they all added up to 180. So when you get one or two, maybe three different expressions, one for each of the three angles, something like that. Okay. I think between the two reviews that are available for this test, you get a good sampling of those kinds of problems. Find the missing sides. Pythagorean theorem. Can you write it down right now for yourself? What's the theorem? Got to be able to do that, right? Call it up. And the important thing to know about that theorem is this one here is the hypotenuse, right? The number that's alone on the right, on the other side there, that's the diagonal. The one across from the right angle, the diagonal. So we're looking for the missing side length. In this case, I'm looking for one of the legs, one of the two sides that makes up the right angle. So that's either the A or the B that we're looking for. It doesn't matter. Here's the other. Eventually, you'll have to do a square root. Use your calculator to do a square root unless it's something really familiar. Subtracting here. And maybe you recognize that one. Square rooting both sides, I'd get a 6. Right? Maybe there's units on there. Watch out for units. Here I am looking for the hypotenuse. So that's the one that's all alone. So 15 squared plus 36 squared equals x squared. Big numbers. I could use my calculator, definitely. I know that one, but I don't know what 36 squared is. One, 2, 9, 6. All right. So add those together. I got 1521 is the square of my value. I have to square root that number. All right. $39. Yep. Notice that 39, not obviously related to 36 or 15 to start with, Not like you can cheat and add them or guess or something like that. Doesn't work. And we did versions of that where, your TV is certain length and width, what's the diagonal, or the computer screen or something. Or there was the kite up in the tree, and you knew how long the string was, but how tall is the tree? Word problems that were designed to create a right triangle that then you applied the theorem to find the missing side. Oh, I thought that was maybe a speak up. Let's see. I kind of quickly went, oh, how about inequalities? Remember those? Let's see, what did I do here? All right, I have a strict inequality. You'll be asked probably to present your answer in interval notation. Am I doing this or the other way around, right? So, what was the one thing that's different than solving equations as normal? If you ever multiply or divide by a negative, then the direction of the relationship reverses. How would I proceed here? The variables being multiplied by 5/2. It's a nice single step you can use to cancel that. Multiply by the reciprocal. Or multiply both sides by 5. See, I do it. By 2/5. Now, I'm multiplying by a positive number. So it does not change the direction of the inequality. My word grab me so much today. That made those go away. And let's see, this, how about -24? Okay, so x is any number less than -24. Now, if I do that on the graph, as we go in that way, notice I put an open circle. You can see that's supposed to look like it's a messy open circle, sorry. But I'm going to -infinity, right? My interval notation. And I'm coming up to, but not quite, including the -24. Lose my negative sign. That's real unfortunate. You go all that work and then you forget your negative. There would be the interval notation for that solution. All right. Do another one. Greater than or equal to, so I'm going to eventually use a bracket on one end of my interval notation, the bracket meaning it gets to be whatever that endpoint is. But this time I'm canceling out that division by -2. I'm going to multiply both sides by -2 and multiplying by a negative. So this will now reverse. Remembering what to do with your multiplying or dividing by negative. So those go away, and that turns into +48. X is anything less than or equal to 48. On my number line, that would be that solid dot, still less than. So again, coming from -infinity, coming up to 48, but we get to include it, so we use the bracket instead of the parentheses. So just watch out for that. If there's a negative, if adding or subtracting never changes anything. It's multiply or divide by a negative. That's what changes that direction. I did a little bit of everything on my list. How about you guys? You folks. Ladies and gentlemen. Old habits, hard to break. see a couple of you have already worked through the recommended review. There's that optional review, additional review problems. You can print out that page and it has the answers on the second page, which is nice. You can check yourself. I encourage you to at least get through one of those reviews. And then I noticed, well, that printed one, the one you can print out, it doesn't have a Pythagorean theorem problem on it. You know, I made sure to do one here. I think the one that's in MOM has something like a Pythagorean theorem problem. It might have been one of those, like a TV or something like that on the diagonal. Anybody else? Like, I was working fast here, but got through a lot of different things. Well, I think I'm good to go if you are, all right? And you know what you've got to do to be prepared, get your work through the reviews. We've got the usual Monday night homework that's due and the hand-in homework. These 3 problems to turn in by tonight. Just a word about this week's hand-in homework. We're into week 6 now. And I looked at it just the way the course was originally set up and how I adjusted the schedule. The hand-in homework for this week really is related to the material that we're about to get tested on. It looks like 3 of those, I'll call them word problem type problems, including the triangle geometry kind of problem. You know, if one angle is twice the other and another one is 4 less than 3 times the other, or something like that. But I think and maybe there's even a percentage problem now, if I recall. But this week's homework, hand-in homework, will look like, well, shouldn't that have been last chapter? So Wednesday, we will start the next chapter. But the hand-in homework for this week really kind of still relates to this previous chapter. Our next chapter really is the, kind of what we're working towards as far as algebra is concerned. Relationships between 2 different numbers, and we get graphs of all the possible solutions. Oh, we got a new student. All right. Okay, so work on your reviews, and I'll be checking in them throughout the day. As usual, tomorrow there's no Zoom class tomorrow during test day. But I will be checking in to make sure you don't have just procedural difficulties, that there isn't some question about how to do something or what it's asking for. And then submit your homework, submit your scratch work. Right? Be sure to do that. Okay, folks, well, I'm going to go then, going to let you go, and good luck tomorrow. And I'll see you all Wednesday. Okay.
Thanks, Steve.
Yeah.